Hi guys, welcome to another video. This is Quantitative. In this video I'm going to show you how to calculate the binomial distribution. Now I'm gonna do question number 2. A lot of fuses contains 10% of defectives. If 4 fuses are randomly selected from a lot, find the probability that 2.1. Now this is a binomial distribution. How do I know that this is a binomial distribution? The notation for the binomial distribution is N and P. This is the notation, which means if on the statement there is N and P, which is the sample size, and this is the probability of success. Now there's N if 4 fuses are randomly sampled. Now N is 4, then the probability of success. A lot of fuses contains 10% defectives, 10% of defective, which is that 10 is the probability of success. So we're going to say 10 divided by 100. Then it will give us 1, because the probability of success, it must be a decimal. That's why I'm converting the 10% to a decimal. Now 2.1, find the probability that exactly 1 fuse. The formula for the binomial is N CR to the power P times P to the power R times Q to the power N minus R. So N, we get N and P from the statement. Then R is the probability that we are calculating, which is we find R on the questions. So exactly 1, which is R is equal to 1. So we are calculating the probability that exactly 1. So P into R is equal to 1. Then the formula N, it's 4, R is 1 to the power P. P is 0.1. You times P, not to the power P, times P 0.1 to the power R. R is 1 times Q. Q is 1 minus P, which is 1 minus 0.1, which gives us 0.9. So times 0.9, 4 minus 1. So we are going to punch it like this: 4, then C, which is we are going to press shift, then go to divide. There's NCR. So after pressing shift, you are going to press divide. There's C. Then we're going to press 1 times 0.1 to the power 1 times 0.9 to the power 4 minus 1, which is equal to 0.292. 0.292. Then 2.2, at least one fuse in the symbol of 4 is defective. At least one fuse, at least one. It's 2.2. So P into R is at least one. Sorry, one. Sorry, at least one. P into R is at least one. Which means the probability from 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. At least one, which means we are calculating the probability of not less than 1. At least 3 or at least 1, which means from 1 and upwards. But it's gonna take time, or it is time consuming to calculate all these probabilities, the probability of 1 and 2 and 3 and 4. So we're going to subtract the ones that are less than 1 so that we get these probabilities. So we're going to subtract the probability that is less than 1 from 1 so that we get the probability of all these. This is at least 1, which means from 1 and upwards. But it is time consuming to calculate all these. So I'm going to subtract the ones that are less than 1, which is the probability of 0. Subtract it from 1 in order to get the probability of all these ones. So 1 minus going to calculate the probability of 0. So n, I'm substituting the same formula. N is 4, CR is 0 times P is 0.1 to the power R, which is 0, times 0.9, which is Q, 0.9 to the power N minus R, which is to the power 4 minus 1. So the answer is, you are going to punch it like this on your calculator. 1 minus 4, then press shift, then go to divide, which is NCR. There's C, then R is 0 times 0.1 to the power 0 to the power 0 times 0.9 to the power 4 minus 1. 4 minus 0, 4 minus 0, sorry. 4 minus 0 there. the answer is 0,344. 0,344. So it's 0,344. I think I'm done with question 2. Now I'm gonna do question 5. Question 5 says an industrial firm supplies 10 manufacturing plants with a certain chemical. The probability that any one firm calls in order on a given day is 0,2, the probability, which is P. Find the probability that on a given day the number of plants calling in orders is. Now I'm going to put the notation N P. So an industrial firm supplies 10 manufacturing plants. Our N is 10. Now the probability that any one firm calls in an order on a given day is 0,2. 0,2, the probability. Now find the probability that on a given day the number of plants calling in orders is at most 3. At most 3. We are going to use the same formula. P to the power R, Q to the power N minus R. So Q is equal to 1 minus P. So 1 minus 0,2 is equal to 0,8. Now 5.1. At most 3. So P into R is at most 3. Is at most 3. Which means we are going to calculate the probability from 0 up to 3. Probabilities of 0, 1, 2, 3, at most 3, which means not more than 3. So the probability of 0, 1, 2, and 3. At most 3, which means not more than 3. We wanted the probability of not more than 3, which is at most 3. We're going to start from 0 because 0 is the number. So we're going to start from 0 up to 3. We are going to substitute with the same formula. So I don't have a space here, so I'm going to calculate the probability of 0 from my calculator and then put the answers. So N is 10, there's 10, then press shift, then there's NCR, press on the divide button. So 0, R is 0. We are substituting the same formula. P is 0,2, 0,2, so times 0,2, which is P to the power R. R is 0 plus 0,8, which is Q to the power N minus R, which is 10, minus 0. Oh, sorry, I thought there was multiply. So it's 0,107. 0,107 plus. Then we are going to calculate the probability of 1 using the same formula, 10 shift. Then R is 1 times 0,2, which is R. R is 1. Then times Q, which is 0,8 to the power 10 minus 1, which is N minus R. So it's 0,268. Probability of 1 is 0,268 plus the probability of 2. So 10 times 0,8 to the power R, which is 2 times 0,2. 0,2 is P, 0,8 is Q. So Q is 0,8 to the power 10 minus 2. Yes. So the answer is 0,302. 0,302. Then plus the probability, the last probability, which is the probability of 3. So we're going to use the same formula. The formula doesn't change. R is 3 times 0,2, which is P to the power R, which is 3 times Q, which is 0,8 to the power N minus R. 10 minus 3. So it's 0,201. It's 0,201. And then we add them all. 0,107 plus 0,268 plus 0,302 plus 0,201. So the probability of at most 3 is equal to 0,878. 0,878. That is the probability of at most 3. At most 3, which means you must start from 0 up to 3. If it says at most 4, you are going to start from 0 up to 4, depending on the question. Now the question says at least 3, which is 5.2. At least 3. So P into R is at least 3. At least 3, which means not less than 3. When it says not less than 3, which means it must start from 3 and upwards. 4, 5, up to 10, because N is 10. Now it will take time, or it will be time consuming to calculate all these probabilities from 3 up to 10. So the shortcut would be to minus these probabilities that are less than 3 from 1 in order to get all these ones from 3 up and upwards. So the probabilities that are less than 3 are 0, the probability of 0, the probability of 1, and the probability of 2. In order to get all these probabilities from 3 and upwards, we're going to subtract these ones that are less than 3. So 1 minus, we already calculated these probabilities from 5.1, so there's no use to calculate them again because it would be a waste of time, because we already have the values. The probability of 0, it was 0,107, so we're just going to write 0,107 plus the probability of 1, which was 0,268, plus the probability of 2, which was 0,302, 0,302, and then subtract them from 1. So we're going to say 1 minus 0,107, 0,107 plus 0,268 plus 0,302. So it's 0,323. The probability of at least 3 is 0,323. 3, like that. That was at least 3. Now 5.3. Calculate the mean and standard deviation of plant calling in orders. The mean and standard deviation. So in the binomial distribution, we calculate the mean like this. Mu is equal to NP, which is N times P. So N is 10 times P, which is 0,2, which is 0,2. So the mean is equal to 10 times 0,2. The mean is 2. The mean is 2. And standard deviation. Standard deviation. Sigma is equal to square root NPQ, which is N times P times Q in the square root. N is 10 times 0,2, which is P, times Q, which is 0,8. So the standard deviation of the binomial distribution is equal to 10 times 0,2 times 0,8 is equal to 1,265. 1,265. 1,265.